Welcome back, physics fans, and we're going to do example number 4 and example number 5 from the first lesson. Okay, and that's on this sheet where we're taking the notes. What is kinematics? Distance, time, position, the change in displacement, speed, velocity, and then we did a few questions, and then 4 and 5. Here we go. Okay. So a runner completes one lap of a circular track, radius 85 meters, in 135 seconds. What's the runner's speed? What's the runner's velocity? So we have an 85-meter radius track. So 85 meters, and that's the radius. The circumference is how far he ran. So because he started here and he ran all the way around and ended up there, he ran one lap. The circumference is where he ran, so it's 2 pi r is the distance that he ran. Okay, so 2 times pi times 85 meters. So we'll go 2 pi 85. Actually, in my calculator, I don't have to do the time symbol if I use variables like that. And this is 534.1 meters. I'll just keep 4 sig figs. Okay, so that's the D. And we are given that the time is 135 meters. So what formula we're going to use? Well, the only one that we really have in this chapter, and that is going to be V is equal to D over T. Now, if D is displacement, then V is velocity. If D is distance, then the V is the speed. So we're going to do the speed first. So we have to put the distance in. And that distance is 534.1 meters. And the time is 135 seconds. Whoops, I got a wrong unit down there. Seconds. And then my calculations will give me the speed. Okay, I'll just I'll do it this way. Speed, because we have to answer it both ways, is, and Mr. Calculator, is that number divided by the time, which is 135, and it's 3.956. 3.956. Okay, and is that right? It sure looks right, right? Meters per second. Okay, well, let's just not do it that way. We'll get the digital rectangle to make it look nicer. Okay, so we box out our answers. And now, what is the velocity? Well, velocity is the displacement over time. And the big question here is, what's the displacement? If we start here, and at the very end, we end up at that same location, the displacement's actually 0 meters, because you haven't ended up in a different location. You might have traveled, but your displacement is 0. So we'll still do it over the time, but 0 meters will give us a velocity of 0 meters per second. Actually, 0 doesn't need any 0 meters per second is 0 kilometers per hour. And even though it's a velocity and you need a direction, an arrow of 0 length can have any direction and it would be right. Okay, what I'm trying to get at with this question is speed and velocity don't have to be the same, especially when you're not in a straight line, which we're not here. And speed doesn't need a direction, and velocity can be 0. Even though you have moved, velocity can be 0. Especially when you, and it only is when you arrive back at the same place that you started at. Let's move on with the next question. Zoom, and let's continue on with number 5 here. The speed of sound is 340 meters per second. That's what I'm telling you right now for this experiment. And the person hears an echo of their voice 3.5 seconds after they speak. How far away is the barrier that is causing the echo? So it looks like we have a speed here, and we have a time here, and we're asking about how far is a distance. So it looks pretty simple, okay? You might want to go v is equal to d over t, and start going that way. And remember, when we speak and we hear an echo, the sound has gone to the wall, hits the wall, and then comes back. Okay? And we want to know this distance. If we put in and rearrange this formula to being d is equal to velocity times time, put a velocity of 340 meters per second in here, and the time of 3.5 seconds. If we do it this way, and it's not horrible, it sure seems like we're doing it the right way. Okay, I take in 340 and multiply it by 3.5, I get 1190. Now, what's that represent? That is the distance you travel if you travel at 340 meters per second at 3.5 seconds, for 3.5 seconds. So that speed times that time, after that, you have traveled 1190 meters. But that's not what it's asking. It's not asking how far has your sound traveled. It's asking for how far is the wall. So it has bounced and gone back. So it basically is this number divided by 2. Okay? And that's going to be 595 meters. Now, to get that without this logic at the end, we could have done the logic beforehand. We could have said, well, if it took 3.5 seconds to go to the wall and back, we could have said that the time to go to the wall is the 3.5 divided by 2, which is 1.75 seconds. 1.5 seconds to the wall and 1.75 seconds to the back. So then we would have gone d is equal to velocity times time, 340 meters per second, times 1.75 seconds, and we would have had that answer right away. Either way, we'd have to end up dividing by 2, dividing the total distance of this in half or dividing the time in half. Going to continue on from the worksheet number 4 and 5. That was from homework. What is the velocity in kilometers per hour of a car that travels 680 kilometers north in 12 hours? So it's velocity, so it's a vector, and we're given a vector for the displacement. That's pretty good. Okay, so v is equal to d over t. You don't need to put these arrows in there, but I'm just showing you that they are what we want. Both of them will have vectors. That's what we get. We got to put a vector in, we get a vector out. The distance is the displacement is 680 kilometers north, and the time was 12 hours. So then we pull up Mr. Calculator and get 680 divided by 12, and we get 56.67 kilometers per hour, and the direction will be the same. And let me just box that off. And I think go, resume this. And we're going to do question 5 from the homework. A runner travels 60 meters at a steady speed of 5 meters per second. So this is a speed, right? That's good. And we're given a distance. That's good. Okay, because if we were given a displacement, it would be kind of weird. Okay, the time taken is, so V is equal to d over t. That's the one formula I gave you. You could have skipped that and wrote down exactly the rearrangement of it. Time is equal to distance over velocity. Or you could have just started with that formula and plugged numbers into it and then rearranged it. Lots of different ways to start on this question, but I'm going to start with the generic one that we're given, the speed formula, rearrange it for time, and then start plugging the numbers into it. So 6 meters, 60 meters, all over 5.0 meters per second, okay? And this is just going to be what, 12? Okay, and let's just verify that the units meters cancels with meters, and if we get 1 over seconds, that's kind of like 1 divided by 1 over seconds, and when you divide fractions, you're actually multiplying the reciprocal, seconds over 1, and that's just going to be seconds. So the units here is just going to be seconds, and I just proved it kind of in a weird way, using fractions, getting rid of that, and that's our answer. Do we need a direction? No. If there was a direction, there isn't. Okay, this was not a displacement and velocity. But if there was a direction, there would have been like a north here, and then a north here, and the directions would cancel out, so the time wouldn't have a direction. And it better not be, because time is a scalar. But let me just get rid of that and box off my answer, because I am complete. It's done. Happy physicsing. Thank you for paying attention. Enjoy.